compound interest. So we've been looking at credit cards and calculating interest on not making payments off credit cards. And in reality, let's make this bigger here. Interest on a credit card isn't only charged once a year. So we're going to look at how it's really calculated. So question number one, suppose you charge $1,000 on a card that charges 12% APR. So what that means is you spend $1,000, the credit card company pays the shops back wherever you spent the money. And if you can't pay them back, they're going to start charging you 12% on the money that you still owe them. So this says find the account balance after 5 years. Try to do this by evaluating a single expression. Write down the expression as well as the answer. So again, we've talked about how interest can be calculated if we have our starting amount, $1,000, and our interest is increasing at 12% per year. So 1 plus the 0.12, because the interest is going up, the amount that we owe is going up, to the power of x or t. I'll put t here. And we're doing it for 5 years, so really I should put the 5 years here. Okay, so this is what it means by a single expression that we evaluate. An expression doesn't have an equal sign, so here it is. Let's calculate how much we owe at the end of 5 years. So in our calculator, pop up the Desmos one. Okay, so we start with $1,000, where the interest that we owe is increasing, so 1 plus the 0.12, which is 1.112. And then it's to the power of, so I'll press that AB button under ABC, and for 5 years. And we can see that now we owe the credit card company not only the original $1,000, but an extra $762.34. And that's how the credit cards make their money. All right, so let me write that down, 176234. So again, this is if we can't pay off the $1,000, we owe not only the original $1,000, but $762.34. That will go towards the credit card company for paying off your debt. And that's how credit card companies make their money, is from people who can't pay off what they charge on the card. If you pay it all off right away, you don't have to pay any interest and you don't owe any money to the credit card company. It's just when you can't pay it off, when you start to get into trouble. So number 2, it says if interest were charged at 12% APR semi-annually, semi means like twice a year instead of once a year, the same card would charge 6% twice a year. So again, instead of 12% at the end of the year, if they charge it semi-annually, it's 6% twice that year. By evaluating a single expression, can you find the account balance after 5 years? So will it be more if they charge 6% twice a year versus 12% once a year? All right, so if we're going to write that up, it's going to be our $1,000, and then it's 1 plus, and it's that 12% but divided by 2 to get the 6% per year. And then if we're paying twice a year, and we're doing it for 5 years, so twice a year for 5 years, we're really doing it 10 times within the 5 years. So here's the new expression that we can write or type in our calculator. So again, we take that 12% divided by 2, and then it's for 10 years. So let's try typing this in. We might need to put parentheses around the 0.12 divided by 2 because we do want to do that first before we add it to the 1. Okay. So let's see, is that more than just once a year? All right, so we have, let's clear this. 1,000 parentheses 1 plus, I wonder if I can just type it in without the parentheses. It's 0.12 divided by, I think we can, 0.12 divided by 2. And then I want to close my parentheses, okay? And then to the power of, oh, I pressed the wrong button. To the power of, and again, it's 5 years, but twice a year for 5 years, so that's 10 times. All right, so there it is. Oh, there's the total, $1,790.84. So yes, if they charge us 6%, but twice a year for 10 years, they do actually make a little bit more money. So let's write that down, 1790.85 about. 1790. Okay, I'm out of room, I'm gonna write it here. That's 1790.85. Okay, so you can see that it is going to be a little bit more than if they just charge us 12% once a year. So 3, it says, would a credit card company get more money from you if they compounded the interest more times throughout the year? So compound means like they calculate the interest more times per year throughout the year. Complete the table below to find out. So we already did the annual. So the annual is in the purple right here. I'm just going to rewrite this. So if it's annually, it's one time a year at 12% per year. So again, this is 12% per year. And then here was the expression. It was $1,000 we started with. It was increasing at 12% a year for 5 years, and we owed $1,762.34. And then we did it semi-annually, which is twice a year. So that's 6% per year, twice a year. So here's how we calculate it. The $1,000 times 1 plus, we divided that, I don't need the parentheses there. We divided the 12% by 2 to get 6% twice a year. But then we did 5 times 2 or 10 times a year because it's 5 years, 2 times a year. And then we got that 1790.85 in red. And we saw that twice a year, even though it's 6% twice a year, which is 12%, that doing it twice that year, they got more interest from us. All right, let's do quarterly. It's like how many quarters in a dollar? There's 4. So quarterly is like taking that 12 and dividing it by 4. 12 divided by 4 is like 3%. So what they're going to do is, ooh, and I made a mistake here, didn't I? I put 0.6, which is like 60%. That should have been 0.06, 6% a year. And again, if we take our 12% divided by 4, we get 3%, but 4 times a year. So really, here's how we would type it into our calculator. We have 1,000. It's increasing. We take that 12%, we divide it by 4 times a year. But then it's 5 years, but 3 times a year. So 5 times 3 are to the 15th power. All right, so I'm going to try typing this green thing, expression here, in our calculator. So let's, oh, do I not, I wonder if I can just delete what I, okay, so I can just delete parts of this. That's nice. All right, so now we're doing it for quarterly. So we'll divide by 4 because it's 4 times a year. Oh, did I type my equation wrong? Let's double check. Oh, yeah, I said 3 times a year, and that's wrong. It should be 4 times a year. Right? So we're calculating it for 5 years, 4 times a year, not 3 times a year. Silly me. All right, so let's change that here. So this will be for 5 years times 4 times. So 5 times 4. We could just put the 20, but I'll just, no, it's not letting me do that. It keeps doing that. All right, I'll just put the 20 here. 5 times 4 is 20. It wouldn't let me type the 5 times 4. All right, so there it is. Oh, look, they've made more interest off us. It's $1,806.11. Let's type that in. $1,806. So we can see that, yes, calculating the interest 3% 4 times a year, they're going to get more money from us. All right, let's do monthly and weekly. There are 12 months in a year. So that's like taking 12%, dividing it by 12. So really they're charging us 1% each month, but 12 times a year. Here's what it looks like that we would type in. So we have our 12%, whoops, divided by 12. And then it's 5 years times 12 times a year. So that's 60 times over 5 years. This is typically what they do for, you know, like car loans and stuff, 60-month loan. All right, let's type this in. And again, we can just kind of edit our equation if it's already in here. Delete. Okay, so this is 12%, 12 times a year. And then we did 5 years times 12, which is 60 times over 5 years. And yes, they made more money off of us, $1,816 and about 70 cents. So $18.16.70. And they are making more money off of us. All right, and then let's do weekly. How many weeks are in a year? And there's 52 weeks in a year. And so our interest would be, I don't know what 0.12 divided by 52 is. What is that? So I'm going to calculate that. So that's a small, it's like 0.0023. Every week, that's the amount that they're going to calculate the interest off. Here's the expression that we would type in our calculator, 1,000, 1 plus the 0.12 divided by 52. But then we're doing it for 5 years times 52 weeks in a year. What is that? 5 times 52 is 260. Okay, so let's type that in. Okay, so now we're doing it 52 times a year, which means that over 5 years, it would be 52. It would be 260. So again, 52 weeks times 5 years is 260 weeks in 5 years, and it now is 1820.86. 1820.86. So we can see that the more that they compound it per year, the more interest we're going to pay. When it was one time a year, we just paid $762.34, and then it increased. But if you notice, it starts to increase by smaller and smaller amounts. So there's a much bigger increase from annually to semi-annually, and then it starts getting smaller. So we have a $10 increase here. Here we only have a $4 increase. So it says right here, try to write an expression using only variables for the account balance. Okay. And if we had more time, what we would do is we would calculate this daily. We could calculate it hourly, and we would find that this amount levels off. And so it levels off. Well, we'll talk about that later. I guess we'll talk about the leveling off a little bit later on, but it does level off. So even if they charged us like by the minute, at some point it would level off, and they wouldn't keep making like a huge amount of money off of us the more they compounded the interest. All right, number 4, try to write an expression using only variables for the account balance A after T years on an initial charge P at an annual percentage rate R, calculated N times a year. So basically they're asking us, all right, we plugged in numbers into these expressions right here. What were we plugging in? So here it is. The account balance that you owe is always your starting value. Okay, so starting value is P times 1 plus, because it's increasing, 1 minus if it's decreasing. And then it was your interest rate, so the 0.12%, so interest rate as a decimal, divided by the number of times per year you're compounding the interest, times the number of years, again, times the number of times per year you're calculating it. All right, so again, it tells us what everything stands for. A is the account balance, P is the initial value, R is the rate as a decimal, N is the number of times per year they're calculating the interest, and T is number of years. Number 5, it says, in reality, credit cards charge interest monthly. Adjust your equation to make it credit card specific. So for monthly, the only thing we would change is we would divide by 12 and then multiply our number of years by 12, because it's 12 times a year for that many years. So that's our compound interest equation. When it's more, when they calculate the interest more than once a year. So I'll just rewrite it. It's the same as above. A equals, so the amount equals your starting value plus your 1 plus your interest rate divided by the number of times per year. And then you take however many years it is, T, and then multiply it by the number of times per year. So there's the fancy equation, but let's take a look at what it would look like in an equation, or in a problem that you would see. Okay, so here's compound interest when it's more than once a year. You buy an iPad Air for $4.90, or iPad Air 2 for $4.99 using a Capital One card. They charge you 19.8% APR compounded monthly. How much will you owe after 2 years if you don't pay anything off of your card? Try to do this by evaluating a single expression and write that down below. All right, so we're starting with $4.99, your iPad Air. Our interest is increasing at 19.8% as a decimal. You divide that by 100, you get 0.198, or move the decimal over twice. We're dividing it by 12 times a year because they're going to calculate that 19.8% per year, but for every month, so they divide it out. And then we're going to do this for 2 years. But it's 12 times a year for 2 years, so really 24 times that they're doing that. All right, let's put this in our calculator and see how much we owe when we originally paid just $4.99. Okay, so $4.99, 1 plus, and then it was 0.198 divided by, and it was 12 times a year, and then we'll close that parenthesis, to the power of, and again, it was 2 years, 12 times each year, that's 24 months. We're doing the payment, and we can see we owe $739.06. $739. That iPad Air was originally about $500. So the credit card company is making about $239 off of you because you can't pay what you owe. So there's the example of compound interest. The main difference is if it's more than once a year, you divide by that amount. but you multiply your time by that amount too. It's the same as annual interest because in annual interest, we're dividing by 1, so we don't write the divided by times. So here's an example of, again, of annual interest. This is what we've already been studying. It says since 1995, the daily cost of patient care in community hospitals has increased about 4% per year. And in that year, the average cost was $968 to stay in that hospital per day, which is why we have insurance, because it's so expensive. So A, write an equation to model the cost of hospital care since 1995. Let X equal the year since 1995 and Y is the cost. All right, so it started at $968. It increased at 4% per year, and then X is the number of years. So here's the equation. It is actually the same as this compound interest equation, but what's happening is we're dividing it by 1 time a year and we're multiplying by 1 time a year. So if it's only 1 time a year, we just do what we've done for the simple interest where we don't divide and multiply. Then it says use your equation to estimate the approximate cost per day in 2018. Let's change that. Let's do 2021. And remember, we started in 1995. 2021 minus 19. All right, so I'm going to figure out how many years that is. All right, it's been 26 years since 1995. So now let's put that in for time, and then we could calculate. So y equals 968, 1.04 for 26 years. How much now would it be to stay in the hospital per day? Oopsies. Let's go to our calculator. Okay, so let's clear this. And it was 968. Was it 968? Now I've already forgotten. Okay, chapter 4. Oh, sorry, that's geometry. Okay, 968, 1.0426. 1.04 to the power of 26. Okay, so now if that trend continues on the same path as growing exponentially, now per day in the hospital, it would cost you $2,683.75. Let's write that down. 2683.75. Was it 0.75? Yes, it was. Okay. So that is exponential growth for you. Grows pretty quickly. So your goal today is to practice more of these review problems where it's simple interest, but then also take a look at if they compound it more than once a year. So your assignment is to complete the next 2 pages in your packet, 29 and 30, and I'll attach that answer key onto Google Classroom so that you can check your answer.